Even with simple sentences, generative AI models can help you quickly render design ideas. This empowers novice designers to try out their ideas. But design can be complex and overwhelming. With materials like the design requirements, client persona, sketches, and mood board that help shape a balance between creativity and functionality. At the same time, novice designers often struggle because they are unfamiliar with specialized design language. For example, saying soft cushioning and curved back is too vague, making it difficult to communicate design details to generative AI tools. When novice designers try to be more specific, they often emphasize superficial features too heavily, such as describing a cushion as cloud-like. This shows how novice designers have trouble identifying and balancing important, deeper design dimensions, like ergonomics or structural balance. Even when novice designers use detailed phrases like backrest that follows natural curve, their language often stays abstract or unclear. This highlights their difficulty expressing complex design concepts precisely, causing generative AI to produce unexpected results. In summary, novice designers often struggle because they are unfamiliar with design language and complex design concepts. This creates a gap between what novice designers envision and what generative AI tools deliver. Our goal is to bridge this gap. To that end, we conducted a formative study with 12 design experts to understand effective strategies for helping novice designers. From the study, we identified 4 key design goals: integrating client needs, surfacing important design dimensions, visually comparing alternatives, and supporting iterative exploration. These guidelines help novice designers navigate design decisions clearly and confidently. Informative study findings inspire us to devise dimensional scaffolding, a technique that extracts key design attributes from generated images and presents them in a structured way. Here we introduce DesignWeaver, a system that supports dimensional scaffolding. In DesignWeaver, participants click text on the different design dimensions to update the prompt. In each iteration, 3 chair renderings will be generated. You can like the images to add them to the favorite folder. Then by clicking the plus button, you can add either recommended or custom tags. Similarly, you can also click Add New Dimension button to add recommended or custom dimensions. By clicking the Info button, DesignWeaver will map the newly discovered text for the image back into the dimensional palette, from which you can keep whichever tag you want to. Of course, you can also manually edit the prompt. Finally, click the image enables inspection. Research question-wise, we focus on 3 main ones: how dimensional scaffolding impacts the prompt user writes, how it shapes generated designs, and how users engage with scaffolding itself. We explore these 3 questions in comparison to a baseline condition, where we remove the dimensional scaffolding features. In the 1-hour-long multi-subject study, we brief our participants about the design task and then train them to either use baseline or DesignWeaver interface. Then, after they use our interface to finish the design task, we will follow that up with a survey and semi-structured interview. To assess effect, we use the following measurements. In the findings section, regarding the impact on text prompt, without scaffolding, novice designers' prompts were vague and lacked depth. making it difficult to produce effective AI-generated designs. With DesignWeaver, novice designers created richer, more detailed prompts that explicitly surface critical design dimensions. Our analysis shows that DesignWeaver prompts were consistently longer over the entire design session compared to the baseline. This indicates novice designers using dimensional scaffolding were able to write more detailed prompts. Also, we found that novice designers using DesignWeaver included significantly more design terms in their prompts as well. The results indicate DesignWeaver effectively bridges the vocabulary gap. Here, we presented the top 3 expert-rated images on Novel-D from both conditions. With DesignWeaver, we can see generated designs were more visually diverse. Quantitative analysis also confirms that designs generated with DesignWeaver are significantly more diverse, as shown by lower similarity score. Expert ratings also validate that these designs are notably more novel. Regarding user perception, participants mentioned feeling overwhelmed by having too many tags and were unsure how specific their prompts could be. However, they also appreciated discovering new design dimensions they hadn't previously considered and valued the flexibility in easily modifying their design exploration. To summarize user perceptions, while some users felt constrained by excessive tagging and mismatched design results, overall, they value the ability to actively control and expand their exploration process. We observed that DesignWeaver led to longer, richer prompts and more diverse and novel design outcomes. Users also reported feeling empowered by adopting new design terms and gaining greater control over their design exploration. Finally, let us look ahead for the open questions in the domain. For some misalignments between novice designers' expectation for AI outputs, we wonder: 1. How can AI better capture and visualize design prompts more accurately? And 2. How can we leverage the misalignments in AI-generated images as potential opportunities for design reflection? Our vision for the future involves generative AI tools that seamlessly integrate visual and textual interactions, instantly adapting to designers' evolving intentions. Looking ahead, we are curious if dimensional scaffolding can effectively support designers in fields like architecture or fashion. Additionally, we want to understand how expert designers might benefit or potentially feel limited by this structured scaffolding approach. Thanks for listening.